Assalamualaikum warahmatullahi wabarakatuh. My name is Dody Setiawan. I'm from Magister of Mathematics Education, Faculty of Teacher Training and Education, Sebelas Maret, University Surakarta. I'm here today to talk you about my article with the title Characteristic of Student Sensory Mathematical Imagination in Hot-Based Problem Solving. This article consists of three authors, namely I am Dody Setiawan, SPG, and my two academic teachers are Prof. Tri Atmojo Kusmayadi, MSc PhD, and Dr. Farida Nurhasanah, MPD. Abstract is, this study aims to determine the characteristic of student sensory mathematical imagination in solving problems based on high-order thinking skill. This study is a qualitative study involving 4 participants in the 8th degree of junior high school. The test instrument used was Hodge-based question to determine the characteristic of student sensory imagination consisting of 2 questions. Triangulation is used to ensure the accuracy of the data. The type of triangulation used was the triangulation of observation method, questionnaire, student answer, and interview result. The results show that the process of student sensory imagination can be seen from the process of solving problem as a result of brain stimulation when thinking. It can also be seen through visual representation, conscious activity, and body movement or motoric sensor. The keyword is sensoric mathematical imagination, perception, and high-order thinking skill. Introduction. The research is based on research on imagination concluded by Samli 2011, White 2010, Wibowo 2017, Chapman 2008, and Nemirovsky 2008. The result of this research is that imagination is important to be involved in solving mathematical problems. Imagination is a main focus and key creativity in effective learning. The basic assumption in this study is imagination can arise when students are given mathematical problem as a stimulus. Students imagine ideas that will be used by involving unconscious physical movement for solving high-order thinking skill-based problem. The ideas that arise in solving mathematics are based on the process of mathematical imagination. Mathematical imagination can be seen or identified based on identification compared to assess imagination. Imagination is divided into 3: sensory mathematical imagination, creative mathematical imagination, and recreational mathematical imagination. But the focus of this article is sensory mathematical imagination. Sensory imagination can be seen through the emergence of ideas based on perception such as problem stimuli. This research is here to find out the characteristic of student sensory mathematical imagination in mathematics problem. Research method. This study used qualitative research with research method based on the philosophy of post-positivism with the researchers as the key instrument. The object of this research is the characteristic of sensory mathematical imagination. While the subject of this study were 5 grades 8 junior school students who were selected based on their mathematical ability and based on a mathematical imagination questionnaire. The question is sheet instrument consists of items that can explore the participant sensory imagination. This test instrument consists of two host items. Data collection technique in this study use test sheet, observation, and interview. The data collected is descriptive data which then analysis include inductively. The strategy used is a case study with a method of collect and analysis data. The data analysis used was a data analysis development by Criswell 2014, which include data reduction, data representation, and data retrieval. Triangulation technique were used in this study to ensure the accuracy of data consisting of data from observation, study, infer, and interview. Okay. Analysis of the characteristic sensoric mathematical imagination host-based problem solving in participant 1 or P1. The analysis of emergence of mathematical sensory mathematical imagination characteristic in host-based problem solving for P1 is presented in chart and table. The activity is carried out by P1 start from the problem until sensory mathematical imagination by P1. Physical activity carried out by P1 is move finger and toes. The results show that P1 is able to generate sensoric mathematical imagination in solving host-based question but does not generate other type of imagination. Second, the analysis of the characteristic of sensory mathematical imagination high-order thinking skill-based problem solving on participant 2 or P2. The analysis of the emergence of mathematical sensory by P2 is presented in chart and table. The activities carried out by P2 starts from the problem until sensory mathematical imagination. Physical activity carried out by P2 is move the rules. The results show that P2 is able to generate sensory mathematical imagination is solving high-order thinking skill-based question but doesn't generate other type of imagination. Third, the analysis of the emergence of the mathematical sensory imagination characteristic in high-order thinking skill based problem solving for participant 3 or P3 is presented by in chart and table. The activities carried out by P3 start from the problem until sensory mathematical imagination by P3. Physical activity carried out by P3 is knocking pen to table. The results show that P3 is able to generate sensory mathematical imagination in solving high-order thinking skill-based question but doesn't generate other type of imagination. And the last, analysis of the characteristic of sensory mathematical imagination in high-order thinking skill-based problem solving on participant 4 is presented in chart and tables. The activities carried out by P4 start from problem until sensory mathematical imagination. Physical activity carried out by P4 is move finger is participant 4 is moving sand from figure 1 to figure 2 and knocking on the table. Discussion. The subject of this study consisted of 4 participants, P1, P2, P3, and P4, who had different characteristics of sensory mathematical imagination, so that in solving high-order thinking skill-based problems, they used different methods as well. The process of the emergence of sensory mathematical imagination in participants is relatively the same, starting with recognizing the problem and the ending with getting a solution. The idea emerged after the participants made a sketch or picture, Assembly 2011. This is reinforced by the idea expressed by Wilke 2006, which states on imagination is involved in producing image manipulation. During the process, participants perform various physical activity, including moving their finger, moving their feet, tapping a pen on the table, looking out the window, and even doing Balinese dancing. The movement of physical activity is a sign of thinking process and generating idea to solve problem. The faster the movement, the more ready participants are to get idea or solve the problem. The emergence of problem stimuli is a trigger from generating idea to solve problem. The idea that emerged from the 4 participants were different. This is support Surya 2013. Opinion that sensory mathematical imagination is subjective, meaning that is concerned with the age condition. Based on the description, the participant only gave to rise sensory mathematical imagination and did not generate other type of imagination. The characteristic of sensory imagination that arise include: first, understanding the problem as a whole. Second, digging up the information contained in the problem. Third, doing physical activities such as moving finger, feet, and moving objects around them. Fourth, describing the overall information obtained. And the last, obtaining appropriate stimuli in the form of a problem then becomes the perception to be idea to solve the problem. Sensory motoric activity play a role in the process of sensory mathematical imagination. From the finding problem to problem solving process, motoric sensory activity is interpreted through physical activity so that it can be seen visually. Conclusion. Sensory mathematical imagination appears when participants explore the information in the problem. The information obtained drives the perception of each participant. Information is the source of the stimulus, and with the stimulus, idea will emerge to solve the problem. Various stimuli that arise result in diverse perception which the from idea. This idea can be offered based on visual representation. Visual representation is a form of sensory mathematical imagination. Motoric sensor activity play a role in the process sensory mathematical imagination. This activity is seen as a physical movement so that it can be visually. Physical movement include moving finger on the table, moving feet, and moving object around. The characteristic of sensory imagination that appear on the subject include understanding the whole problem, finding important information in the problem, doing physical activity, describing the overall information obtaining, and obtaining appropriate stimuli in the form of problem then become a perception to be idea to solve the problem. Sensory motoric activity play a role in the process of sensory mathematical imagination, from finding problem to problem solve process. Motoric sensory activity is interpreted to physical activity so that it can be seen visually. And the last, acknowledgement. We thank all of participants in study. Thank you very much. The last say, wassalamualaikum warahmatullahi wabarakatuh.